All right, everybody. So we're starting Module 5, which means we're going to be going back and looking at exponents. And we want to think of exponents as a short way to write a number. It represents the number of times a number is multiplied to itself. So, for example, if we wanted to expand 5 to the second power, that means this exponent tells me how many times 5 gets multiplied to itself. So there's 2 times it's getting multiplied to itself. What number is getting multiplied to itself? That 5 is. So this would be 5 times 5, or 25. All right. So what about 2 to the negative 2 to the third? Okay, same thing. There's 3 of them. It's all multiplication. So this would be 2, negative 2, times negative 2, times negative 2. And we would think this is negative 8. So what do you think expanding b to the 6th would end up looking like? Well, the exponent, there's 6 of them. 1, 2, 3, 4, 5, 6. It's all multiplication. So this would be 6b's all written out. And this is why we use exponents a lot with variables, because unlike these ones up here where I can find a final answer like negative 8, I can't do that with a variable. Okay. Now, if I said something like b equals 2, then we could say, oh, well, that means I can take 2 and plug it in all these. But that's not what the problem says, right? So that's why we're going to see variables a lot with exponents, because we can't simplify them any further. We don't know what that number is. And this last one, this one should be the quick and easy guy, is there's only one 5,000ths. There's no multiplication that's happening. It's getting nothing past the regular multiplication there. Okay, so it's just 5,000. So what we should be able to do is rewrite these thinking what would be the exponent if I were to write these out. So this first one, you should think, how many 3's are there? There's 4 of them. It's all multiplication, so this is 3 to the 4th power. The next one, m times m times m times m, we would count them up. We'd say, okay, I have m being repeated. It's multiplication, so it means I'm going to have an exponent. Count them up, and we get 7 of them. And this last one looks weird. How do we simplify this? Well, it's not that we need to simplify. We want to write it with an exponent. So if you were to write this as an exponent, I know I have 213, and how many of them are there? There's only 1. This is 213 to the 1st power. Okay, so there's our quick review for exponents, and we're going to introduce something new today. That new thing we're introducing is what happens if the exponent is 0. And this is one of a pretty straightforward rule. Okay, it's one of the most straightforward rules you're ever going to get in mathematics. If you have an exponent of 0, it simplifies to 1. What does that mean? K to the 0 power is 1. 6 to the 0 power is 1. Whatever's inside this box, when we raise it to the 0 power, 4m to the 0 power is 1. It's all 1. So anytime you see a 0 power, you should automatically be going, that's 1. I can do that. And it doesn't even matter if it's a variable, right? This is just kind of like if you had b minus b, that's 0. Anything minus itself. This is the same kind of concept. Anything raised to the 0 power is 1. And so here they had 4 different, this one was 6 to the 1st. Sorry, I'm using Miss Fry's PowerPoint and didn't realize that there was a line through there already. Which one of these is not simplified to 1? Any number to the 0 power, this is 1. M to the 0 power, that's 1. This whole thing, raised to the 0 power is 1. This guy would not be. This means there is 1 6. Okay? So pretty straightforward on that. Anything raised to 0 power is 1. So beat that one into your memory. That's going to be one of the rules we use. And we're going to be, in the live lessons and the note guides, building a chart of all our different rules. 0 exponents the rule is it's always 1. So you should go ahead and fill in those examples on the right-hand side. Now, your task for today's live lesson, I want you to bring me 3 different problems. Let me make this text box a little better. 3 different problems using variables and exponents. Please remember, we're going to be working with these, so you might want to be careful on the numbers. Some examples of what you can bring. Let me make that thicker. M to the 4th. Or you could bring me something like 2k squared. Anything like that. I want 3 of them. Okay? 5v to the 5th. Something like this. Okay? Bring me 3 of them. Do not use any addition, no subtraction. The only thing I want is multiplication. You can use a coefficient. That's what the 2 and the 5 would be here. These guys. A variable and an exponent. Bring me 3 of those, and we will work with them in the live lesson. You guys will see what we'll be doing with them. All right? So enjoy your day. We'll see you guys in the live lesson. Have a great one.